Okay, we're about to do a review of last week's work. So the first thing we're looking at is what differentiation is. Differentiation, this is a process which is used to produce an equation that will give the slope. Another word for slope is the word gradient. Gradient and slope mean the same thing, of a function at any required point on the original graph. The words and phrases and symbols that you need to learn are as follows. You need to know that the words slope and gradient mean the same thing, and that rate of change also means slope. You need to know these phrases. These phrases, slope of function, or slope of line, or slope of curve. The phrase slope of tangent to a function, and the phrase gradient of a function, they all mean the same thing. They mean differentiate. They mean differentiate. So it's really important that you get that into your heads. The symbols for slope, well, you already know some of them. Symbol for slope from second and third year is m. Now we've got something called dy by dx, also sometimes called the rate of change of y with respect to x. And finally, you also get a function which is f dashed of x. And these all mean the same thing. They mean slope. Now moving on to page 2. And on page 2, quick reminder of last week, we have to be able to differentiate three distinct functions. Power of x, which is y equals x to the power of n. When you differentiate the y, you get dy dx. And when you differentiate a power of x, you multiply by the power, and then you put the power down one. So that's, hopefully by now you've learned that phrase. Multiply by the power and put power down one. Linear functions. We know from last week, last lesson, that dy dx, when it's a linear, we know the linear power, that the slope is given by the number in front of the x. So dy dx is technically we just drop the x. And again, when we differentiate y, we get dy dx. And when we differentiate a constant, the answer is 0. Now, just do a quick reminder of last week's work once again. If we've got 3x to the power of 4 minus 3x, let's make it 8x squared plus 4 over x cubed minus the third root of x to the power of 2. The most common error is that people will start to differentiate this. They will do dy dx, because that's what happens. You differentiate y, you get dy dx. They then will do 4 3s, multiplying by the power, put the power down 1. Then they will do 2 8s, which gives you minus 16, and then they put the power down 1. And of course, then they suddenly realize, this is in the wrong format. And without thinking, they start changing it. But if you realize you get to a point where something is in the wrong format, then the best thing you can do is cross everything out or rub everything out, whatever's easiest for you, and start again. And when you start again, you must remember that now you're not differentiating, you are rewriting. Therefore, because you are doing a rewrite, then the y stays the y. The 3x4 stays as 3x4, minus 8x squared stays as this. And then you've got to remember from the laws of indices that you're bringing the x cubed up. So it becomes x to the power of minus 3. Then you've got to remember from the laws of indices that this thing here is a cube root, which means when you remove the root symbol, you are creating a fractional power, and the 3 goes on the bottom. Now they are all powers of x. All of these are powers of x. And because they're powers of x, we can now differentiate. So back to where we started, dy dx, because we're differentiating the y, it becomes dy dx. Multiplied by the power, I think we're all good enough now to do 4 3s are 12. Multiply by the power, 4 3s are 12. Put the power down 1, 3. Multiply by the power, going to be minus 16. Put the power down 1, it's going to be 1. Multiply by the power, it's going to be minus 12. A minus on a plus is a minus. Minus 12. Now be careful. Put the power down 1. When it goes down 1, it goes from minus 3 to minus 4. And then here we're going to multiply by the power. So we're multiplying by 2/3. And then we put the power down 1. If we're putting the power down 1 in our heads or off to one side, we're doing this. 2/3 minus 1. And 2/3 minus 1 is equal to minus 1/3. And that's going to be the new power. So in here we put minus 1/3. Now, that's a quick revision of last week's work. Let's do something new. It says here, well, actually, no, we did this last week as well, but we'll quickly whip through it. Find the equation of the tangent to the curve y equals 3x squared minus 6x plus 5 at the point 2, 5. Well, what does it mean? Well, it means that we have a quadratic. It's a positive quadratic, so it's roughly going to look like that. A tangent is a straight line. It's a tangent to the curve. It's a straight line that touches the curve at one point. And the point that they're saying it touches it at is the point 2, 5. We've been told to find the equation of this tangent. Now a tangent is a straight line. And we know that the equation of a straight line is y minus y1 is equal to m on x minus x1, which is a formula from the junior cycle. We also know that the point is 2, 5. So we can advance this formula one line on. Y minus 5 is equal to m on x minus 2. Now the thing is, we need to work out the value of m. M, of course, is slope. And we've learnt over the last couple of lessons that slope is also dy dx. So m is also dy dx. And where are we going to calculate the slope of this line from? Well, the slope of a tangent is also the slope of the curve at that point. The slope of a tangent is also the slope of the curve at that point, which means we can come up here and we can write this down and we can differentiate it. So we get dy dx is equal to 6x minus 6. What value of x do we have for this slope? The value of x we have is x equals 2. So now what we're going to be doing is we're going to find dy dx when x is equal to 2, which is got from over there on the left-hand side. I'll highlight it so you know where I've pulled it in from. So we now have got dy dx is equal to 6 on 2 minus 6, and 6 on 2 minus 6, unfortunately, is equal to 0. Oh no, sorry, brain's going. 6 times 2 is 12. 12 takes 6, so the slope is equal to 6. So dy dx is equal to 6. Therefore, m is equal to 6, and that's the m that we're going to be bringing up and putting into here. So we bring this down, and we've got y minus 5 is equal to m on x minus 2. So we've now got y minus 5 is equal to 6 on x minus 2. So y minus 5 is equal to 6x minus 12. So y equals 6x minus 12. Bring the minus 5 over. That's going to become plus 5. So y is equal to 6x minus 7. And that is the equation of the tangent to the curve at the point 2, 5. And that was just a reinforcement of last week's work. Next example. It says here, find the points on the curve at which the slope of the tangent, is 9. Now, we already know that the phrase slope of tangent from earlier on in this lesson is another way of saying dy dx. The word is another way of saying equals. So what we have there is we have been told dy dx is equal to 9, and we are now going to be looking for points. And points, of course, is x and y values. So let's just follow where it leads. We know that y is equal to x cubed minus 3x squared. We are required to do dy dx because of what's here. So dy dx is now equal to 3x squared minus 6x. What do we know about dy dx? Well, we know it's equal to 9. So therefore, we know that dy dx is equal to 9. How do we know that? Well, because we were told it over here. Dy dx is equal to 9. We also know dy dx is equal to 3x squared minus 6x. So we know from junior cert, if two items are equal, then what they're equal to are also equal. So we now have that 3x squared minus 6x is equal to 9. We're going to divide everything by 3 because it's an equation, which means we can divide both the left-hand side and the right-hand side. So 3's go into 3 once, so we end up with x squared. 3 goes into 6 twice, so we've got 2x. And 3 goes into 9 3 times, so we've got 3. We can then bring it over, and we have a quadratic equation equal to 0. So all the way through this, we're just following our nose, see where the mathematics actually takes us. First times last is 1 times minus 3, which gives us minus 3. Looking for factor pairs, 1 and minus 3, when they add up, they give minus 2. So yes, they're the correct pair. So x squared plus 1x minus 3x minus 3 is equal to 0. The common factor for the first two is x. So we've got x on x plus 1. And we cheat because we know that's going to be x plus 1 is equal to 0. And then we look for what's common here. And what's common here is minus 3. Always double check. Minus 3 on x is minus 3x. Minus 3 on plus 1 is minus 3. So we know that we have got it right. So we can continue with the factorization. So we end up with x plus 1 on x minus 3 is equal to 0. So x plus 1 is equal to 0. X minus 3 is equal to 0. So therefore, we've now got x equals minus 1, and we've got x is equal to 3. Now, you need to be very, very careful. You need to read the question, because the question clearly stated that it wanted the points, and the points are of the equation y equals x cubed minus 3x squared. So we need to find the y values for this equation. So I'm going to write it down here. Y is equal to x cubed minus 3x squared, and y equals x cubed minus 3x squared. Using the empty bracket method, empty bracket cubed minus 3 empty bracket squared. Here the same thing, empty bracket cubed minus 3 empty bracket squared. Inside this brackets, we're putting minus 1. Inside this bracket, we're going to be putting the 3. We're now going to work it out. Minus 1 to be cubed is minus 1. Minus 1 to be squared is plus 1. So it's going to be minus 1 minus 3. It should be minus 4. I would check that if I were you. I was doing it in my head. We're now going to get, this is going to be, the input number was minus 1. The output number was 4. The input number for this one is going to be 3. Now, I haven't worked out the output number. 3 3s are 9, 3 9s are 27, minus 3 3s, 9, 3 9s are 27. So that's going to be equal to 0. So therefore, the input number was 3, and the output number was 0. That's the end of that example. Moving on. I know I'm going quite quickly, but may I remind you that you can stop this video anytime. You can pause it. You can review it. This is the last example was new, and this is also new. We're going to be looking at something called the chain rule. And here's an irony. I want you to completely ignore, for the time being, this formula. And I want you just to use common sense based on what I'm about to say to you. I want you to picture opening up an Easter egg. And the first thing you do is you unwrap the outside, which is the box. The next thing you unwrap is maybe the silver foil, which is round the Easter egg. And then you will attack the chocolate on the Easter egg, and then you'll get at whatever's inside. In the old days, it could be a toy or something, a prize. But you start at the outside and you work your way in. Now, this is what the chain rule is. So I'm going to try and explain to you now that, first of all, you cannot differentiate this at the moment because you have a square root symbol. So now the first thing you've got to do is you've got to change the square root symbol into a power of 1/2. And this is the outside function. And we call this function A. And this thing in here, x squared plus 5x minus 2, is priority B function, second division. We're now going to differentiate. You can stop and you can play this over again and again. When you differentiate f functions, you put a dash. Now, we said if it's the chain rule, if you've got an outside function, then you have to differentiate the outside function first. That's what I mean by unwrapping. You have to differentiate the outside function. How do you differentiate a power of a half? Well, you multiply by the power, and then you put the power down one. And when you put it down one, the half becomes minus a half. Now, the important thing to remember is that when you unwrap the box, you don't do anything with the foil. And this is the same here. This is still now x squared plus 5x minus 2. Now what you do, and this is very important you learn it, you multiply by the differential of what was inside, looking at the priority b bit. You multiply by the differential of what was inside. So multiply by the power, put the power down one. A 5x just becomes plus 5, and the minus 2 becomes 0. And that's the answer. Let's look at example 13.1. 13.1, you've got a chain rule question because you've got f of x is equal to 3x plus 1 to the power of 3. Now, I've been a bit silly here because I've left it a bit tight, but we'll see what we can do. This outside function is the one that we focus on first, so we call it a. This inside function, we focus on it second, so we call it b. I'm now going to differentiate this, and it's going to be f dashed x is equal to, now we focus on the function on the outside. We're unwrapping the box. By unwrapping, we are differentiating. So we're going to be multiplying by the power, and then we're going to be putting the power down one. And the inside bit does not change. And then we put brackets. And what we've got to remember now is that we are now going to be multiplying by the differential of b, which means we're now going to be multiplying the differential of 3x is 3, the differential of 1 is 0. And that is not the final answer, because you could bring the 3 to the front, and 3 3s will be equal to 9. So we could just finish this off by saying f dashed x, the 3 comes to the front, we end up with 3 3s are 9, and then 3x plus 1 to be squared. We can't bring the 9 inside because the power takes priority. And now we've got the last one to do. And it's exactly the same as the one above. We've got y is equal to x to be squared plus 3x all to the power of 3. This is the priority a function, and this is the priority b. So we're going to be differentiating it. This time, because it's y, we're calling it dy dx. Dy dx. The differential of y with respect to x. We look at the outside function first. We look at the a. And then that means we're multiplying by the power, and we're putting the power down one. The inside bit does not change. And then we do a bracket, and then we differentiate the inside bit and write the answer in here. So that's going to be 2x plus 3. And that is the end of the problem. Moving on. Now, we're moving on to something called the product rule. And the product rule is very, very simple if you learn it in words. So over here, I'm writing UV, and that's the product of two functions. And we call this one the first function, and we call this one the second function. And if you look at this formula here, we've now got, come back to here, what is u? Well, u is number 1. And what's v? It's number 2. And what's v? It's number 2 function. And what's u? Number 1. Now, it's very important that you follow what I'm about to say, because what you have here is you've got the first function times the differential, d for differential, of the second. So we're going to be writing this in words. So dy dx, according to this formula here, it is going to be the first function times the differential of the second function plus the second function times the differential of the first function, because d stands for differential. So we end up with this abbreviation: the first times the differential of the second plus the second times the differential of the first. And there below you will see written in words, and what I would like you to do is not necessarily learn this, but be able to translate it from the diagram above. Be able to translate it from the diagram above. The first times the differential of v, the second, plus the second function, which is the v, times the differential of the first. Now, what we're going to do is we're going to see it in practice. So let's just bring this down here and give us a bit of space. So clearly, what is the first function here? The first function is the first bracket, first, and there's the second. What's the formula? How do we know this is a product? Because it's one item multiplying another. Because it's one item multiplying another. We look at the formula book and we discover that the formula is dy dx is equal to u dv dx plus v du dx. How does that translate into English? Well, dy dx is now equal to the first function times the differential of the second function plus the second function, which is v, times the differential of the first function. Over here, I'm now going to write down what 1 is. The first function is equal to x squared minus 4. The second function, because it occupies the second position, is equal to 3x cubed minus x squared plus 9. So now I'm going to differentiate the first function, the differential of the first function, and that's equal to 2x. And now I'm going to differentiate the second function, and that's equal to 9x squared multiplied by the power, put the power down 1, minus 2x to the power of 1, and the plus 9 is going to become 0. So all I have to do now is sub it in. So dy dx is equal to the first, which is x squared minus 4, multiplied by the differential of the second, multiplied by the differential of the second, and the differential of the second is written there. And differential of the second is 9x squared minus 2x to the power of 1. Then the formula goes on to say plus, so there's a plus, and it's the second function, and the second function, don't forget we always substitute into brackets, is 3x cubed minus x squared plus 9 times, according to the formula, the differential of the first, and the differential of the first is 2x. Now, you would probably be expected in your textbooks to sadly multiply that out and tidy it up. Such is life. Now we're going on to the quotient rule. And it's very important that you make a distinction between how we describe. When you've got a fraction, you describe this u here to be the top. And this thing here is going to be the bottom. So now, as I slowly go through this formula, what have we got? We've got the bottom times the differential of the top minus the top times the differential of the bottom. And if you look at the line below, then I've written it in English, and that's what you should do. You should learn it in English. Bottom times differential of top minus the top times differential of the bottom, and then don't forget all over the bottom squared. And now we're going to see this in practice. When you actually write out that formula, you can quote it using abbreviations. I was just about to write dy dx, but in the context of this problem, it's not dy dx, is it? Because they gave us g of x, in the context of this problem, the differential is g dashed x. And g dashed x will be the bottom times the differential of the top minus the top times the differential of the bottom all over the bottom to be squared. Over here, we're going to write down what they all are. The top is 2x minus 3. So the differential of the top is going to be equal to 2. The bottom is going to be equal to x squared minus 4. So the differential of the bottom is going to be 2x. So all we've got to do now is sub this in. All we've got to do now is sub this in. So we have g dashed x is equal to the bottom, and the bottom is x squared minus 4. Don't forget, when we write something, put it into brackets, times the differential of the top, which is 2, minus the top into brackets, 2x minus 3, times the differential of the bottom into brackets, which is 2x. And don't forget, all over the bottom squared. And the bottom, of course, is x squared minus 4. So that's all squared. You are expected to tidy the top up. You are never expected in an exam situation to expand the bottom. I think the textbook does that. It's wrong. Shouldn't be doing it. As I've been talking, I hope you've noticed that I didn't do any working out. What I did was I brought the items that were on the right-hand side to the front. And the reason why is because there's less likelihood of making a mistake if you do it that way. I just want to draw your attention to what I did. I brought that 2 and I wrote it there, and I brought that 2x and I wrote it at the front. And now that means it'll be a lot easier to work this out. So you're going to end up with 2x squared minus 8 minus 4x squared plus 6x all over the bottom to be squared, which generally speaking, we do not, under any circumstances, work out. Which we do not, under any circumstances, work out. And then all we've got to do now is finish off. So the answer is minus 2x squared plus 6x minus 8 all over x squared minus 4. And I think you'll be pleased to hear that that is the end of the activity. This isn't one lesson's work due to circumstances beyond my control. I'm not able to do any live streaming of lessons this week. So this is at least 3/4 lessons worth done in one go. Thank you.